Value engineering in BIM is a review process where a construction design is analyzed to find ways to make it more efficient and inexpensive. Value is directly proportional to what you want and inversely proportional to what you pay. Lesser cost plus enhanced functions equal better value. BIM is revolutionizing the construction industry through its powerful 3D modeling capability. Most of the design work is done by multiple consultants who are geographically apart from each other. Through BIM, all the design elements come together in one place. BIM offers a range of benefits to the AEC industry. Of all the benefits, one of the most important is value engineering, or VE, which doesn't receive the attention it deserves. This graph shows the correlation between value engineering and the different stages of construction. The earlier value engineering is introduced into the overall construction process, the better. This is because a higher amount of savings can be realized by avoiding major changes at a later stage. How does BIM facilitate value engineering? The 3D model in BIM enables a high degree of visualization, which allows us to review designs meticulously, tweak them, and lay routing. BIM provides a comprehensive view of all the services at the same time. Our highly experienced architects and engineers review designs meticulously to perform a value engineering analysis. We use several designs and analysis software and in-house software modules to create multiple iterations of a BIM model to optimize its cost and maximum value. Benefits of value engineering: low material cost. As per the input drawings, the cable tray length was 200 feet, horizontal offset 7, with 42 hanger supports. After value engineering, the cable tray length was 78 feet, horizontal offsets 2, hanger supports 17. Hence, we reduced the material cost by 60% per floor and installation time by 60%. This is an 18,000 square foot residential building. As per the IFC, the rack had 100 clevis hangers and 300 fittings. After VE, the pipes were organized and trapeze hangers were replaced with clevis hangers. This reduced the number of hangers to 50 and fittings to 150, resulting in low material and installation costs. In this commercial residential building, the initial pipe length of the cooling tower was 164 feet with 100 fittings. After value engineering, we reduced the pipe length to 65 feet with 50 fittings, hence saving 64% of material cost. Low operational costs. As per the IFC, the room had 20 lights and an average lux of 21.3 foot candle. The average power consumption was 500 watts. The standard lux range for this room is 19 to 28 foot candle. After VE, we reduced the number of lights to 16, with the average lux being 19.7 foot candle, which is within the standard range. Hence, the power consumption reduced to 375 watts. Therefore, we saved approximately $10,512 over a period of 10 years, typically for 20 rooms, which is a 20% reduction in operational costs. According to the input drawings of the chiller pump in this multi-storied building, its power consumption was 100 kilowatts, which was higher than necessary. After VE, we optimized the energy requirement of the chiller pump and reduced the power consumption to 80 kilowatts. If we assume 12 cents per unit of electricity and 6 hours of average running per day, then the total savings over a 20-year period will be $105,120. This graph shows higher system efficiency, resulting in low operational costs. Low labor costs. As per the initial plan, welding was suggested to facilitate the passage of horizontal rebar through the steel beam. Welding elements to steel affects its strength and increases labor cost. After VE, the passage of rebars was facilitated by drilling holes into the steel beams to ensure the strength of the steel wasn't affected while keeping labor cost low. Easy maintenance. Inline equipment, FPV, was placed above the hard ceiling as per design documents, where we would have to add an access panel for maintenance. After value engineering, we were able to move the FPV above the acoustical ceiling for easier access during maintenance. Short installation time. In this commercial building, welding was advised for fire protection. Welded seams take several hours to install and are high maintenance. After VE, we suggested groove couplings because they can be installed quickly and are low maintenance. This reduced the overall installation time by 6 hours per floor, which is 60% less than the welding process. At Pinnacle, value engineering is integrated into our BIM process, and we value engineer every project at no additional cost. We've been providing value engineering services to countless clients across the globe for the past 23 years. Get free VE analysis of your BIM model at ve@pinnaclecad.com.